Hello friends, good morning. Today we will talk some other important topic of CBSE standard, physics under the heading Physics Made Simplest. So I will talk today about the photons and the photoelectric effect. And then we will do some problems. The photoelectric effect. As the word, you see the meaning photoelectric effect means electricity produced by photons, you can say in simple language, that photons interact with certain metal substance and what we observe at this photoelectric effect is observed when light or the waves of certain frequency, you can say, this is a phenomena when radiation of suitable frequency interact with the metal surface. So that is the phenomena observed when frequency, certain light or certain radiation fall upon a metal plate and they interact to produce, then what happens? The frequency is light radiation of certain frequency. Remember, the frequency is very important. That is the energy. You know, waves or the waves or radiations, energy written as E is equal to h nu, where nu is the frequency, h is Planck constant. This is after the Planck's quantum theory, that Planck suggested that we assume light as the quanta of energy, that is of certain frequency. So light or the waves represented by energy E is equal to h nu, h the Planck constant and nu is the frequency. So when this frequency, the light or the radiation of this energy fall upon a metal plate, what happens? It is observed that particularly certain alkali metals sodium, potassium, calcium, these etc. show photoelectric effect when you see the light, when the radiations or the visible light when visible light of say around lambda is around say 4000 angstrom to out 8000 angstrom. This wavelength falls on them. Certain alkali metals, sodium, potassium, calcium, etc., show photoelectric effect. When visible light, lambda, this ray, fall, this interact with the falls upon them. So it is observed that so what happens is that when this frequency, this wavelength, or you can get the energy E equal to h nu or h3 over lambda. So lambda you can put here. So that way, when this energy or this wavelength, you can calculate energy, fall upon the metallic plate, what happens is the from the atomic shell, electrons are emitted and electrons make a current because electron flow. Current is nothing else but the flow of the electron. So electrons come out and electron make current, they flow. So like that you can make say you can represent this by certain diagram. Say you have say you can say some closed vacuum tube and you have here electrode and here you have some another electrode, anode or cathode, and here you have say a battery, say source of the potential, and here you connect a emitter, say like a microammeter, and light is falling from the source here. Radiation is coming from this side. You have a window here. So from this window, radiation is falling here. Radiation is coming out, radiation is falling here, and here is the window, you can say. So this radiation is falling on this negative electrode, that is the cathode, and we have battery here. This negative here, they are falling here, they constitute a current because electrons come out. So electrons flow in this circuit and the current about microampere order will flow. So this is the photons or the radiations falling upon a metal cathode. Here this is a metal cathode that I told you, sodium, potassium, calcium, like metal cathode, and this is the anode, say plus, this is minus. So electrons come out and they are attracted towards the positive because positive potential is there. So a field is there. So due to electric field, electrons flow. and they make a current. That is the photocurrent. Photocurrent is flowing. So this makes flow of current flowing through this. And remember that this current flowing, by experiment you can do experiment that you can measure the current, you can change the potential, etc. So you can observe some effects, what experimental results are. Experimentally it is observed. What is observed experimentally? You see, experimental observations are experimental observations. What are the experimental observations? When this experiment was done, that radiation of suitable frequency falling upon this metal cathode, it is observed. What is observed? If the frequency of incident radiation is less than a particular frequency, that particular frequency is called a threshold frequency. This is called threshold frequency. So if the frequency of radiation is below that frequency, no electrons are emitted out. That you can say nu naught. No electrons. If the frequency of incident radiation is less than a particular frequency called threshold frequency nu naught, no electrons are emitted out. This is observation from the experiment. No matter how great the intensity of radiation, no matter the intensity of radiation is increased to any value, this means the photoelectric current doesn't depend upon the intensity of light. It depends upon the frequency, that below this frequency you put any amount of light, photoelectrons will not come out. And above this frequency they will come out. And then you increase the intensity, then the light electric current will increase. But below this is called threshold, means it's starting. Below this frequency, photoelectrons are not coming out. This is the observation. And what is observed, that the velocity or the energy, you can say, the velocity or energy, you can also say, or kinetic energy, of photoelectrons the velocity or kinetic energy of photoelectrons doesn't depend upon the intensity of light, the intensity of radiation. So this, as I told you, that it depends upon the frequency and not the intensity. So velocity or kinetic energy of photoelectrons which are emitted is independent of the intensity of radiation. No matter how much intensity of radiation will increase, doesn't depend. Of course, not depend upon the intensity, but the kinetic energy or velocity of photoelectrons depend upon what? This depend upon the frequency of the radiations. So the kinetic energy or the velocity of the photoelectrons which are coming out depends upon the frequency. More frequency means more energy of the photon. The kinetic energy of photoelectron increases as the energy of the radiation increases, that is the frequency increases. Accordingly, the photoelectron's kinetic energy also increases. So this is the experimental result. But it is observed that beyond the certain frequency, above the nu naught, that is the threshold, it is observed that if the intensity of the radiations is increased, if the intensity of the radiation is increased above the threshold, above the nu naught, when the frequency of above the nu naught, when the intensity that is increased, the photocurrent also increases. Below nu naught, no, it will not come out. But above the nu naught, if you increase the intensity of the radiation, photocurrent will increase. The photocurrent also increases accordingly. So, these are the observations. So, it means that what the statement, this observation, you can write in terms of say equation that you can write. We can write a mathematical expression that you see the E energy of the radiation E, which is h nu, this is equal to kinetic energy of photons, that is the photoelectrons, plus h nu is equal to this energy plus h nu naught, or this is called work function, or also you can call the binding energy. Binding energy of electrons. Which electron coming out? H nu naught. This is written in some books they write as the W naught, that is the binding energy, or H nu naught. H nu is the kinetic energy. This total energy of the radiation is the kinetic energy of electron plus W naught, or that is H nu naught, you can write. So that is the whole energy of the incoming photon is shared by kinetic energy of electron and the work function. The energy required to remove the electron from atomic shell, that is called work function, or the minimum, that is the threshold energy. So if the frequency is increased above this, that nu, this increases means energy increases. Of course this is constant, obviously this will increase. So as nu is increased, T will increase. That is W naught is constant. So this is the observation that as the energy increase, energy of the radiation, that is the photon, coming photon increase, this will increase kinetic energy of photon. You can observe by the same experiment that one type of the experiment, that by changing the frequency or by changing the wavelength, means by dropping the light of different frequency or different wavelength, you can do the experiment. We can do experiment using, say, photons of different frequency or wavelength. Means we allow the different wavelength light to fall upon the plate, cathode plate, and we measure the photocurrent. And we can do an experiment like this, that or you can do, say, that is this experiment, your light of different frequency of wavelength allowed to fall, and you can use the potential variable battery and to see that by which voltage you apply some voltage, that is electrons or photocurrent is stopped, means it is made zero. That is also possible. This experiment can be done. Means you can verify, you can have a graph, you can plot a graph of this type, that is say different frequency or what you call photoelectric current, the intensity. One experiment can be done on the intensity. This side, intensity of light, of frequency nu more than nu naught, above threshold. It is observed that you can intensity on this side, you increase the intensity I. On this side you measure current. The frequency must be more than nu naught. It is observed that a straight line, different points may fall on this, that this experiment can be done. That as the intensity increases, current also increases. So this current may be say in microamperes, photocurrent may be in microamperes. So that as the intensity increases, intensity keep its frequency constant, but above nu naught. This will be observed like that. This is experiment done like this. And one experiment is done that you use the power supply of say variable voltage. Means here you are in the setup you are using a power supply to stop the electrons. Means you do the experiment where in this here in the cathode and here this power supply is of variable voltage, positive and negative, and this is the variable. Current meter here, and you see that this you can do means you can change the potential. You can in fact you can reverse the voltage. Yes, you can reverse the voltage, means make this as the positive and this as the negative side, like this. So that the electrons coming out from this, here you have now negative potential, so you stop the current. Means you can use the variable power supply and change the potential here to stop the current. Means electrons are coming out from here, electrons are coming out, but by the negative potential they are stopped. So that is the one experiment can be done. That is the what is the voltage required the experiment can be done to measure the stopping potential. To measure the stopping potential. Means we can apply here potential so that the potential stops the electron. Means stop potential means that makes current zero. That is called stopping potential. Means you apply, say, certain potential in go and increase, current will decrease and finally current will be zero. So means that electrons will be stopped. So what is the potential which makes current zero, which stops the all the electrons to reach the flow in the, so that you can say that but keeping the frequency constant. Frequency is constant, you are changing this potential only. Light falling on this of the frequency nu, that is constant but above nu naught, above threshold. That can be done. So this experiment here, potential you are changing. So what potential is applied so that current becomes zero, keeping the frequency constant. So that is possible, and that will decide that what is the stopping potential which is making current zero. So that gives the potential, will decide the energy. Let's say, you can say kinetic energy when, what is the potential? So that is the potential means if V is the stopping potential, which makes current zero, this will decide the energy of electrons. And we can write, say, some expressions. I will explain you those expressions, that what expressions we can write. We can write, say, expressions like kinetic energy in the form of the kinetic energy of the, say, electrons, or the maximum kinetic energy. Because it stops means electrons of maximum energy, they are stopped. So we can write, say, kinetic energy of electron, and that is maximum. This is equal to E into V naught, where V naught is the stopping potential, and that means 1 by 2 m V square, that is maximum, is equal to E V naught. V naught is the stopping potential. So this value of V naught, which makes the current zero, let us say V naught here, applied here, this makes the current, means this stops maximum energy electron. That will give you the maximum energy of electron from the V naught. E is the electron charge. So 1 by 2 mv maximum velocity of electron is equal to EV. This gives the kinetic energy of electron. This is one relation you can get. And you can get, say, other, we can have already the energy another relation we can get. We can write simply that the kinetic energy of electron or the frequency, from the frequency we have h nu, we can now write, that h nu, the energy of photon, is equal to now the kinetic energy, maximum kinetic energy of electrons, that is 1 by 2 m v max square plus W naught, or that W naught which is equal to H nu naught, that is the work function. So this is the energy of electron and this is the energy of the photon which is coming out, and that is the, so this is the maximum. Energy of electron may be less than this, but this is the maximum energy. So this type of relation we can have. And you can, this is the frequency of the light or radiation falling on this. So all this relation can be verified experimentally. You can also get, say, one type of experiment that you have you increase the frequency and you can measure this V naught, that is by changing light radiation frequency nu, means by changing, we can measure different values of V naught, that is stopping potential. Because as nu increase, that means energy increase. This energy will increase. This energy means electron. This energy means the stopping potential. More potential is applied to stop electron. So this stopping potential. And we can get we can plot a graph, say, of this type, that here, like frequency, you have nu, the frequency increasing. On this side you have V naught, stopping potential. We can get this type of graph. Points will be on this different frequency. And this is cutting here is nu naught, that is the threshold frequency, or so this will give a value of nu naught, that is the threshold frequency. Means what is the frequency of light or radiation below which any amount of light you can allow to fall on the metal plate, a photoelectron will not come out. So that is the threshold frequency, nu naught. So this type of experiment, using different voltage V naught from the power supply and changing the frequency of the radiation, means light of different nature, red light, yellow light, ultraviolet, like that. So you can have different value of nu, and you will find it will be different value of V naught to stop the electron, to make the current zero. So that will give a stopping potential, and this relation can be verified. That is nu naught, you can find out W. Thus, W naught is equal to H nu naught is determined. What the value of W naught for particular metal plate, that we can get. So this is you can say the photoelectric effect, which is a very important photoelectric effect, and you can also do the more experiments like changing the metal plate means you have now different plates, so you will get different U naught. That's just for verification of all this. This is possible that you change the metal plate, you will get different U naught. For one particular metallic plate means cutoff frequency or threshold frequency is fixed. So by changing the metal plate, you can get the different value of nu naught. And by changing the intensity of light also, you can do the experiment. Change the potential, change the intensity of light. So different types of experiment can be done. Like say one experiment on the same with the same setup, you can do experiment like that. You have the potential on this side. That potential value is increased to stop the current. On this side potential. On this side you have photoelectric current. Photo current. It is observed that and you have low intensity and high, keeping the plates constant, you are changing the potential, more potential applied, so current will be, because this potential, low potential will stop low energy electrons, current will decrease. More potential means or more electrons of having high energy stop. More potential further means further electrons stop and current decreases. Finally current becomes zero because the potential becomes maximum. So that will give you the mostly here you can say that the current is almost constant, and here there is negative potential because this is the positive potential keeping current, all electrons are collected. This is the positive and this is the negative potential B. So you apply negative potential to stop the current. Here current becomes zero. So this is this value of negative B. How much potential? This is the maximum value of this, making current zero. So that, or you can have say further higher intensity, low intensity of light. Intensity. Here you have high intensity change, high intensity. So the potential is positive, all electrons are collected, so current becomes constant. But on this side, current decreases so that this becomes zero current. Current becomes zero means, this means B max is same value because the energy of electron for one particular light, one particular plate is constant. So this, but you change the intensity, more current will be there, but the B max value will be same to make zero. So this you can confirm that by increasing say light intensity more or less, we can confirm that we wrote V naught probably, that V naught is constant. V naught will not change. The potential, because the maximum energy of electron depends upon the intensity, not intensity but the energy, that is the nu. So intensity you may have any value, energy of photo electron remains same, maximum value, so V naught remains same. So that is the confirmation. This experiment can be done. So that is this current is the saturated because all electrons are collected. So this current becomes constant, that is the saturation current. So this very important effect this you can say that here we have the photon means particle nature of the radiation. So this type of photoelectric effect particularly means what the importance of this photoelectric effect is, that photoelectric effect means photoelectric effect means what? Photoelectric effect means conversion of light into electricity. Light means waves, you can say, or radiation. Anything you can say, into electric current. So this is the important effect because this has got tremendous application because you are converting photons, energy quanta, which is light of different range, means red color, yellow color, green color, violet color, any wavelength, so any frequency, into current. So conversion of one type of energy into other energy. You know, energy can be converted. Energy produced from matter, energy can be converted into matter, and matter can be converted into energy. But so all the forms of energy are same. That I say God is one, universal, one form, and others are having different shapes, means energy different. We say God comes in the different forms. So scientifically it is the energy of different types, sound energy, electric energy, say mechanical energy. All the energy are same because they can come into same. So matter converted into any energy, and all energy can be converted into one matter. That is here photoelectron. So only they change the shapes. Otherwise it is only one thing, energy. So energy, the whole universe is filled of energy. From a small drop, small of energy, a matter is created, huge amount of matter. Or all matter is finished, changed to energy, huge energy produced. So any type of energy can be converted into other energy, transformed to other energy, because this is the same form. It can be converted to energy or matter also. So, but this has very important application because you can convert photons. So all the electronic systems like TV sets, etc., we are using this. You can say photocells are means photon converted into electron current. So photoelectric effect can be used in photocells. Photocells means you convert one type of energy, that is the radiation, into the current. So that is the photon converted into electron current. So the photocells has got tremendous applications. Photocells are used in the industry, various industries. All different types, wherever we want to convert the one form of energy into current, electric. And reverse also possible. From the electric current we can produce the light also. So the photo cells are used. You see, then we have solar cells, where we use the solar cells means we produce the current from the heat, that is radiation, from the sunlight. So solar cells, photo cells are different types of applications of photoelectric effect. That is solar energy. Solar cells means solar energy. So solar energy, photoelectric cells are used in the, say, different types of electronic equipment. I don't want to name them. Any type of equipment wherever light is converted into electric current. So this has got tremendous application. Now we can have some just the application of the formula which we have written. Using this, we can do some problem like, say, calculate the energy of a photon calculate the energy of photon, calculate the energy of photon in EB, calculate the energy of photon in EB where wavelength is whose wavelength is 4000 angstrom. If the photon is having wavelength 4000 angstrom, what will be its energy? Simple thing. We know that E energy is equal to h nu or hc over lambda. Lambda is the wavelength, c is the light velocity. So just you can find out. We know h is equal to 6.62 into 10 to the power minus 34. Yeah, joules second unit, and c, light velocity, is 3 into 10 to the power 8 meters per second. So you can put this lambda is 4000 angstrom, means 4000 into 10 to the power, this is about 4 into 10 to the power 7 meters per second. Because 3 is 10, so 4000 to 10 to the power 10. So 4 into 10 to the power, minus 7, angstrom means 10 to the power minus 8. So this is the lambda 4000 angstrom means 4 into 10 to the power minus 7 meters. 5 per second, meters. So you can put all this, you can get energy E. You get the energy as 6.62 into 10 to the power minus 34 into light. There is a mistake. I think 4000 4000 into 10 to the power minus 8 minus 4000. Yeah, it's not okay. This is the HC, C over lambda. So lambda is, well, C is the light velocity, so 3 into 10 to the power 8 and divide by lambda. Lambda 4 into 10 to the power minus 7. You can calculate this. This will be 4.96 into 10 to the power minus 19 joules. 4.96 into 10 to the power minus 19 joules, which can convert into EV, or E is equal to 4.96 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19 to convert into EV. So this will be about 3.1 electron volt. So this is the energy of this light wavelength. You can say visible light is around 2-3 angstrom. 2-3 angstrom, so this is a fourth of 2-3 EV energy, electron volt. 3 electron volts here. So visible light lies in this range, 2-3 EV. And similarly, we can try some more examples. Say, what is the frequency of a photon? What is the frequency? What is the frequency of a photon whose wavelength, what is the frequency of photon whose energy is 75 electron volt? If this is the energy, what is the frequency? So just using same formula, you can write, say, E is equal to H nu. Say E is equal to H nu. Using same formula, or nu is equal to E upon H. Because what is the frequency? They want frequency, but energy is given. So E upon H, and you have E energy given 75 electron volt. E is equal to 75 EV, converted into joules. So this will be, say, 75 into 1.6 into 10 to the power minus 19 joules. The energy in joules. And H is given 6.62 into 10 to the power minus 34 joules second. So we can get nu, frequency nu is equal to E over H. E over H means 75 into 1.6 into 10 to the power minus 19 divided by H, 6.62 and 10 to the power minus 34. So you solve this, you will get nu, the frequency of the light or radiation. So just it is 18 into 10 to the power 15. 18 into 10 to the power 15 hertz frequency. So this is very simple. Okay. like this. You can do the problems. So we can stop today here, and we can we can do more problem like this. We stop here.